Hello everybody, we are back for Activity B of our Waves Gizmo. In Activity B we are looking at wave dynamics. Please make sure that your Gizmo is reset with an amplitude of 20 centimeters, a frequency of 0.75 hertz. Have your tension set to 3 newtons and your density set to 1 kilogram per meter. The question we are asking in Activity B is what factors affect the wavelength, speed, and power of waves. Number 1, the speed of a wave is the distance a wave pulse travels per second. The wave speed is displayed below the spring. Click play. What is the wave speed? So if we hit play, we can pause that again. We see that our wave speed is 173.2 centimeters per second. I'm going to write that down because we're going to know that number for what we're doing next. Okay. Number 2, experiment. The wavelength and speed of a wave can be influenced by many factors. Adjust the amplitude, frequency, and tension and density as described in the table below. Then report whether this causes the wavelength and wave speed to increase or decrease. Return each variable to its original value after each experiment. So we are going to be looking at increasing the amplitude, increasing the frequency, increasing the tension, and increasing the density, and seeing what that does to our wavelength and the speed of the wave. So first up, let's reset. We're going to increase the amplitude. So, as we can see, our speed is actually going to remain the same, and our wavelength is definitely going to increase. So it increases the wavelength and has no effect on the speed. Okay, we're going to reset. We're going to put our amplitude back to 20. And now we're going to increase the frequency. So looking here, again, we can see the wave speed stays the same, so we have no effect on the wave speed. However, definitely shortens or shrinks our wavelength. Okay, so our wavelength is actually going to decrease. So let's reset that, get our frequency back to 0.75. And now we're going to increase the tension. And now we notice a change in wave speed. It went from 173.2 to 200 centimeters per second. So our wave speed increases. Okay, and as you can see, we can't even find a second crest on our screen here. So our wavelength is going to increase as well. So when we increase the tension, both the wavelength and the speed increase. Let's reset, get our tension back to 3 newtons. And now we're going to increase the density. Okay, I'll let that run for a little bit. We'll pause it there. And now we can definitely notice 2 crests in the same page. So our wavelength decreased, and our speed is now at 122.5. Again, our original was 173. So when we increase the density, both the wavelength and the wave speed are going to decrease. Let's reset our wave and see what we need to do for number 3. Number 3, analyze. Click reset. Set the frequency to 0.8 Hertz, tension to 2 newtons, and density to 2 kilograms per meter. Click play and then click pause. Turn on show rulers, and we're going to be looking for the wavelength and the speed. So we need to set the frequency to 0.8. We need the tension to be 2 newtons. And we need the density at 2 kilograms per meter. And we're going to click play. And then we're going to pause it, and we're going to click show rulers. And we need to record the wavelength. And again, that is the distance from the tip of two crests that are next to each other, or 2 troughs. Okay, so we're going to go up here, and we're going to measure this at roughly, we're going to call it at about 126, we'll call it 126 centimeters. So for 3A, our wavelength is 126 centimeters. We see down here, our wave speed is 100 centimeters per second. So 3B is 100 centimeters per second. Now when we go back, 3C is asking us, how are the wavelength, frequency, and wave speed related? Okay, you need to look at the information that the data you just gathered. You need to tell me how the wavelength, the frequency, and the wave speed are related. Moving on, in general, the wave speed v can be calculated from the frequency f and the wavelength lambda, I believe this is called, using the formula v equals f times lambda. D, what is the wavelength of a wave with a frequency of 0.9 Hertz and a wave speed of 154.9 centimeters per second? So if we write that down, it's going to look a little something like this. Okay, so what we need to do is we need to do 154.9 divided by 0.9. That's going to get us our wavelength. Okay, so when we do 154.9 divided by 0.9, we end up with a wavelength of 172.1 centimeters. Okay, so our answer for 3D is 172.1 centimeters. Now, to check, we can set the frequency to 0.9 Hertz, the tension to 2.4 newtons, and the density to 1 kilogram, and then we can measure our wavelength and see if we're correct. So why don't we do that? So we need our frequency at 0.9. We need the tension at 2.4. And we need our density at 1 kilogram per meter. We'll pause it there.